Fresh observations of the mysterious interstellar visitor 3I Atlas are revealing properties that, well, challenge everything scientists thought they knew about this cosmic wanderer. What initially appeared to be a straightforward comet from another star system is now displaying characteristics that have some researchers questioning whether we're dealing with something far more extraordinary. The object's bizarre orbital path, suspicious timing, and anomalous behavior patterns are sparking intense debates in the astronomical community. Could this visitor be more than just another space rock drifting between the stars? Fresh observations reveal mysteries. The latest observational data from 3Y Atlas has sent shockwaves through the international astronomical community, revealing properties that really defy conventional understanding of interstellar objects. Advanced spectroscopic analysis conducted by Dr. Alan Fitzsimmons at Queen's University Belfast shows inconsistencies in the object's expected water ice signatures, even though it looks comet-like as it approaches the sun. Unlike typical comets that develop prominent tails and comas as solar heating sublimates their icy surfaces, 3I Atlas displays minimal outgassing activity that seems, honestly, artificially suppressed. The object's brightness variations follow patterns that suggest either an extremely unusual internal structure or maybe potentially artificial modifications to its surface properties. Dr. Michelle Bannister from the University of Canterbury notes that the thermal signatures just don't match any known class of natural celestial bodies, creating a scientific puzzle that's got researchers scrambling for explanations. Ground-based observations using the Keck Observatory have detected anomalous reflectivity patterns across different wavelengths, suggesting surface materials or structures that shouldn't exist on a primordial comet from interstellar space. These mysterious characteristics are forcing scientists to consider possibilities they previously dismissed as purely theoretical, opening up discussions about the true nature of our enigmatic cosmic visitor and whether it represents humanity's first encounter with something genuinely extraordinary. The scientific debate. The scientific community has become deeply divided over 3Y Atlas, with heated debates emerging between researchers who maintain it's a natural comet and those who suspect something far more extraordinary. Dr. Robert Warwick, who discovered the first interstellar visitor Oumuamua, argues that 3I Atlas exhibits typical cometary behavior, consistent with objects ejected from distant planetary systems during their formation phases. However, a growing faction of astronomers led by prominent researchers is challenging this conventional interpretation based on mounting observational anomalies. Dr. Matthew Knight from the University of Maryland emphasizes that while unusual properties don't automatically indicate artificial origins, they do warrant serious investigation rather than dismissal. The debate has become particularly intense regarding the object's thermal behavior, orbital characteristics, and structural properties that seem to contradict standard models of interstellar comet evolution. Traditional planetary scientists argue that exotic conditions in other star systems could naturally produce such anomalous objects, while skeptics point to the accumulating statistical improbabilities surrounding 3I Atlas's trajectory and timing. This scientific schism reflects broader tensions within astronomy about how to approach potentially paradigm-shifting discoveries without abandoning rigorous scientific methodology. The controversy has prompted unprecedented international collaboration as researchers desperately attempt to resolve fundamental questions about this cosmic visitor before it disappears forever into the depths of interstellar space. The artificial origin hypothesis. Harvard astrophysicist Dr. Avi Loeb has emerged as the most prominent advocate for considering artificial origins for 3E Atlas, drawing on his controversial analysis of Oumuamua to argue for serious investigation of extraterrestrial technology hypotheses. Loeb's Galileo project, established specifically to search for evidence of alien artifacts, has allocated significant resources to studying 3I Atlas, using advanced observational techniques and artificial intelligence analysis systems. His team argues that the object's unusual properties, including its suspicious orbital alignment, minimal outgassing despite solar proximity, and anomalous structural characteristics, collectively suggest possible artificial construction or modification. Loeb emphasizes that dismissing extraordinary possibilities without thorough investigation represents scientific prejudice rather than rigorous methodology, particularly given the unprecedented nature of interstellar visitors. His hypothesis proposes that 3Y Atlas could represent a reconnaissance probe or derelict spacecraft from an extraterrestrial civilization, deliberately designed to appear comet-like while conducting systematic observations of our solar system. Critics argue that Loeb's theories lack sufficient observational evidence and rely too heavily on speculation rather than proven scientific principles. However, his work has sparked crucial discussions about how the scientific community should respond to potentially revolutionary discoveries that challenge fundamental assumptions about our place in the universe. The debate continues to influence funding priorities and observational strategies for studying this and future interstellar visitors. Unusual detection pattern. The discovery timeline of 3I/Atlas reveals some deeply troubling patterns that, honestly, suggest the object may have been deliberately avoiding detection during its approach to our solar system. Even though it entered our solar system in early 2024, the object wasn't discovered until June of the following year, 2025. That means it spent over a year traveling through space without triggering any of our advanced detection networks. Dr. Catalina Oiza from the European Space Agency points out that, objects of this size should have been detected much earlier by automated survey systems like Atlas and Linear. This really raises questions about how it managed to remain hidden for so long. The object's approach vector from the galactic south actually placed it in a region of the sky that receives less intensive monitoring, which might explain the delayed detection but also suggests, perhaps, some knowledge of our observational blind spots. What's even more concerning is that there's evidence 3I/Atlas may have altered its trajectory slightly during its undetected approach, and this is based on retroactive analysis of archival telescope data that initially dismissed some faint signals as imaging artifacts. Dr. John Tonry, who leads the Atlas detection system at the University of Hawaii, admits that the object's discovery pattern represents a significant failure in current detection protocols. This delayed recognition has cost us precious observation time and honestly, raises some uncomfortable questions about whether other undetected visitors have passed through our solar system unnoticed, potentially conducting systematic surveillance of Earth and, human civilization. Suspicious orbital characteristics. Statistical analysis of 3I/Atlas's orbital trajectory reveals probability patterns so, improbable that they're forcing astronomers to question whether its path through our solar system could possibly be natural. The object's alignment with the ecliptic plane, the flat disk containing most planetary orbits, shows a deviation of less than 0.2 degrees, which is a precision that occurs in fewer than 0.2% of random interstellar trajectories according to orbital dynamics models. Even more remarkable are the calculated close encounters with multiple planets during its passage, including near-miss approaches to Venus, Mars, and Jupiter. Altogether, these encounters represent probability odds of about 0.005% for a natural occurrence. Dr. Davide Farnochia from NASA's Jet Propulsion Laboratory describes these orbital characteristics as, quote, statistically suspicious, and says they're worthy of detailed investigation rather than just casual dismissal. The trajectory analysis also shows that 3I/Atlas will achieve optimal positioning for observing Earth's electromagnetic signatures, like our radio communications and radar emissions during its closest approach phase. Now, some skeptical scientists argue that unusual orbital alignments do occasionally happen in nature and don't automatically indicate artificial guidance systems. But the cumulative probability of all these observed characteristics really challenges conventional explanations. Computer simulations run by planetary dynamicists show that achieving such precise orbital parameters would require either some extraordinary cosmic coincidences or maybe deliberate course corrections throughout the object's journey. These findings have sparked some serious discussions about whether 3I/Atlas might actually represent evidence of intelligent navigation instead of just natural gravitational influences during its passage through our solar system. The hidden approach strategy. Perhaps the most disturbing aspect of 3I/Atlas's trajectory is its perihelion timing, which, honestly, creates a strategic blind spot for Earth-based observations during the most critical phases of its passage through the solar system. The object's closest approach to the Sun happens when Earth is positioned on the opposite side of our star, which severely limits our ability to observe it during the period when thermal effects should be most pronounced. Statistical analysis shows that only about 7% of random interstellar trajectories would produce such observationally challenging timing, suggesting either an extraordinary coincidence or maybe deliberate planning to minimize detection and study opportunities. Dr. Paul Chodas from NASA's Center for Near-Earth Object Studies points out that this timing pattern would actually be ideal for a reconnaissance mission trying to study our solar system while avoiding detailed scrutiny from Earth-based instruments. This positioning allows 3I/Atlas to conduct close-range observations of multiple planets, including Earth, while staying mostly hidden behind the Sun during its most active phases. What's even more concerning is that evidence suggests the object's brightness variations follow patterns that hint at controlled orientation changes, potentially optimizing its observational capabilities while minimizing its visibility signature. Critics, of course, argue that this interpretation leans too heavily on circumstantial evidence and ignores natural explanations. But, the accumulating patterns are becoming pretty difficult to dismiss as just pure coincidence. Scientific opposition and evidence. So, the mainstream astronomical community, they've mounted some pretty strong opposition to these artificial origin theories. Their main point is that, extraordinary claims require extraordinary evidence, and honestly, that kind of evidence just hasn't been provided for 3I/Atlas. The Space Science Institute, for example, emphasizes that while unusual orbital characteristics and timing coincidences are definitely intriguing, they don't really constitute proof of intelligent design or extraterrestrial technology. Leading cometary scientists also point out that interstellar objects naturally show properties that are pretty different from solar system natives, and that's mostly because of their exotic formation environments and exposure to harsh interstellar conditions over millions of years. Now, when it comes to size estimates for 3I/Atlas, things get even trickier. The numbers are, highly uncertain, ranging anywhere from 5 to 20 kilometers, and that depends a lot on assumptions about surface reflectivity and composition, so making a definitive characterization is, honestly, extremely difficult. Dr. Quanzi Ye from the University of Maryland, for instance, argues that the object's minimal outgassing could actually result from surface processing during its interstellar journey, rather than from any kind of artificial suppression of natural comet activity. Spectroscopic observations have detected conventional water ice and carbon-based compounds, which are totally consistent with natural comet composition. Still, proponents of artificial origin theories point out that camouflaging technology could, in theory, easily incorporate such materials. All in all, the scientific debate here really reflects some fundamental philosophical differences about the burden of proof and, what the appropriate response should be when we come across anomalous observations that challenge our established paradigms. Ancient origins and anomalous behavior. Age determination studies suggest that 3I/Atlas may be over 7 billion years old, making it significantly older than our solar system and, raising some big questions about its formation environment and subsequent history. This extreme age implies the object formed during the early phases of galactic evolution, when stellar metallicity and planetary formation processes were dramatically different from what we see today. Despite its comet-like classification, 3I/Atlas displays virtually no visible tail or coma development, even during close solar approaches, which really contradicts some fundamental principles of cometary physics and sublimation processes. Dr. Colin Snodgrass points out that the object's thermal infrared signature just doesn't match standard models for water-ice sublimation, suggesting either an unusual composition or maybe even artificial thermal regulation. Structural analysis, meanwhile, indicates internal density variations that seem inconsistent with natural accretion processes, potentially implying deliberate construction or modification over geological timescales. The water-ice spectrum also shows anomalous absorption lines that don't perfectly match laboratory standards, hinting at either exotic crystalline structures or contamination with unknown materials. And if that wasn't enough, there are periodic brightness fluctuations that occur independently of the object's rotation, which suggests internal activity or controlled surface changes, rather than just simple light reflection from a tumbling asteroid. Taken together, these ancient origins and anomalous behavior patterns create a compelling case for detailed investigation instead of premature dismissal. since 3I Atlas may represent our first opportunity to study technology or materials from civilizations that evolved billions of years before Earth even formed. The stealth hypothesis. The concept of deliberate concealment adds, honestly, a chilling dimension to the 3I Atlas analysis, suggesting the object may be operating under dark forest theory principles, where advanced civilizations actively avoid detection by potentially hostile neighbors. This hypothesis proposes that 3I Atlas represents sophisticated camouflage technology designed to appear as a natural comet, while actually conducting systematic reconnaissance of our solar system and Earth's technological capabilities. Dr. Seth Shostak from the SETI Institute acknowledges that, while this idea is speculative, stealth hypothesis explanations account for otherwise inexplicable observational patterns, better than conventional astronomical models. The perfect timing of its approach, strategic positioning during key observation windows, and minimal electromagnetic signature could all indicate advanced concealment protocols developed by civilizations with millions of years of technological evolution. If confirmed, these stealth capabilities would suggest that 3I Atlas represents technology far beyond anything humans currently understand, potentially indicating that extraterrestrial surveillance of Earth has been ongoing for extended periods without our detection. The implications here extend well beyond simple scientific curiosity to fundamental questions about human security and our readiness for contact with advanced civilizations that may be studying us from the shadows. Now, critics argue that stealth hypothesis thinking promotes paranoid speculation rather than rigorous scientific analysis, but proponents note that dismissing possibilities just because they're unsettling is more emotional than logical reasoning. The debate continues to influence both scientific methodology and public policy discussions about how humanity should prepare for potential contact with extraterrestrial intelligence operating within our cosmic neighborhood. Lessons from Oumuamua. The scientific community's response to 3I Atlas has been, in many ways, heavily influenced by the controversial handling of Oumuamua back in 2017, when humanity's first confirmed interstellar visitor was dismissed as merely unusual, instead of potentially extraordinary. Dr. Avi Loeb argues that the astronomical establishment's rejection of artificial origin possibilities for Oumuamua represents a missed opportunity that really shouldn't be repeated with 3I Atlas. The earlier visitor's anomalous acceleration, extreme elongation and lack of outgassing were explained away through increasingly complex natural theories, rather than seriously investigating simpler artificial explanations. Today, our detection capabilities and analytical techniques are way more advanced than during Oumuamua's brief passage, providing unprecedented opportunities for detailed characterization of 3I Atlas before it disappears into interstellar space. The James Webb Space Telescope, advanced spectrometry, and artificial intelligence analysis systems now offer tools that were unavailable or underdeveloped during our first interstellar visitor encounter. The lesson from Oumuamua is clear. It's important to investigate all possibilities, including extraordinary ones, rather than defaulting to conventional explanations that may not adequately address observed anomalies. 3I Atlas represents potentially humanity's second and possibly final chance to properly study an interstellar visitor during this generation, making thorough investigation crucial, no matter the initial skepticism. Scientists worldwide are coordinating unprecedented observational campaigns to ensure that this opportunity isn't wasted through premature conclusions or insufficient data collection. The stakes honestly couldn't be higher, since 3I Atlas may be our last chance for decades to determine whether we're alone in the universe or sharing it with advanced civilizations. The mystery of 3I Atlas continues to deepen with each new observation, challenging our understanding of what's possible in the cosmos. Whether it's an ancient comet with unusual properties or, something far more extraordinary remains hotly debated among scientists worldwide. What do you think about these strange findings? Could we be witnessing our first confirmed encounter with extraterrestrial technology? Share your thoughts in the comments below, and don't forget to subscribe to Sci and Y, and hit the notification bell for more mind-bending space mysteries. Keep questioning the universe. Interstellar space begins where the sun's influence fades, and the solar wind finally yields to the raw plasma of the Milky Way. Since 2017 we have confirmed just 3 visitors from that vast realm: the puzzling Oumuamua, herald of surprises, volatile comet Borisov, and now the outsized newcomer 3I Atlas. Each object is a priceless sample return mission delivered for free by nature, letting us probe chemistry, structure and age far beyond the planets. Tonight we collect every solid fact astronomers have pieced together about this latest cosmic ambassador. Beyond the heliopause, our interstellar visitors. The solar system's frontier is the heliopause, a shifting magnetic shell standing roughly 18 billion kilometers from the Sun. When Voyager 1 pierced that frontier in 2012, its plasma detector confirmed the long-predicted transition into interstellar space. Densities jumped, solar origin particles vanished, and cosmic ray counts spiked. Since then, terrestrial telescopes have reverse experienced the same crossing by spotting travelers arriving from the galaxy's dark sea. The odds are daunting. Dynamical models suggest only a few hundred-meter-scale bodies wander through the inner solar system each century. Yet modern wide-field surveys and continuous sky patrols have already netted 3 confirmed interstellar objects in just 8 years. Their hyperbolic speeds, inbound directions, and inability to be captured by solar gravity reveal origins that lie light-years away. Each new detection is therefore a planetary science windfall, a primitive shard of another star's debris disk, altered by eons of irradiation and micrometeoroid pummeling, finally falling within reach of Earth's spectrographs. As instrumental sensitivity grows, researchers expect a steady trickle of similar emissaries, gradually transforming Exotica into a statistically rich field of comparative planetology. The third visitor, 3I/ATLAS Discovery. On June 2025, the twin Schmidt telescopes of the Asteroid Terrestrial Impact Last Alert System swept across the pre-dawn sky and registered an object moving too fast to be bound to the Sun. Alert messages flashed from Hawaii to South Africa and onto the Minor Planet Center, where the trajectory was confirmed within hours. Principal investigator Dr. Larry Deneau announced the team had netted 3Y Atlas, humanity's third verified interstellar wanderer. Early photometry implied a remarkable diameter between 10 and 20 kilometers, at least an order of magnitude larger than Oumuamua. That sheer size promised ample reflected sunlight for spectroscopy, galvanizing observatories on 5 continents to obtain time-critical data. Infrared spectra hinted at complex organics, millimeter-wave receivers searched for exotic volatiles, radar attempted shape reconstruction when geometry allowed. The discovery also demonstrated how automated pipelines, artificial intelligence vetting, and instantaneous worldwide coordination can turn a few faint pixels into an unprecedented international campaign within a single rotation of Earth. 3. Y Atlas thus became both a scientific target and a systems engineering triumph, showing that planetary defense infrastructure doubles as an accidental interstellar object early warning net. A hyperbolic journey at 58 kilometers. Trajectory solutions from JPL's Horizon system reveal 3I Atlas, racing along a hyperbolic trajectory with an inbound heliocentric speed of 58 kilometers per second. Calculations by Dr. Davide Farnochia show the path threads the orbits of Mars and Jupiter before the object slingshots back toward the galactic northwest, never to return. That excess velocity, nearly 3 times Earth's orbital speed, guarantees the visitor is unbound. No realistic gravitational interaction could capture it. Dynamical backtracing suggests 3Y Atlas last crossed the galactic plane 30 million years ago, and may have originated near the Carina Sagittarius spiral arm, though stellar encounter uncertainties are large. During its brief stay, it will feel weak but measurable tugs from planetary masses, allowing researchers to test n-body propagation codes under extreme boundary conditions. The rapid passage also forces astronomers into a sprint. Every observing window must be filled, sometimes with instruments never before aimed at the same target in a single night. Lessons learned from these coordination drills will feed directly into mission concepts such as ESA's Comet Interceptor, designed to launch quickly toward the next unpredictable celestial visitor. Brightness, rotation, and the 29-hour cycle. Time series photometry from the Nordic Optical Telescope reveals these quasi-periodic brightness swings of about 9/10 of a magnitude. This maps onto a rotation period of, well, around 29 hours. Data from the European Southern Observatory confirm an irregular, likely elongated body, Its long axis could exceed 9 kilometers, which is quite something. Now if we invert the light curve, it suggests an axis ratio of approximately 3:1. This is comparable to Oumuamua's extreme proportions but on a much grander scale. The stability of this amplitude argues against the idea of loose rubble. Instead, it seems that 3I/Atlas might possess a cohesive monolithic core. This core is likely overlain by mantling regolith that accumulated during its galactic journey. Surface scattering models propose alternating patches of dark carbonized crust and brighter, possibly icy facets. These rotate into sunlight, driving the observed flux pattern. Continued monitoring aims to detect Yorp-induced spin-up or subtle precession. These phenomena could reveal internal density gradients. Polarimetric measurements planned for perihelion will test whether charged particle implantation or interstellar UV processing has glassified surface grains, a state never observed on indigenous comets. So, every rotational cycle opens a time-lapse window onto geological processes, operating far beyond the reach of any spacecraft. Coma, tail, and cometary activity. Solar heating at 1.5 astronomical units would normally trigger vigorous sublimation in an ice-rich nucleus. Yet, the Spitzer Space Telescope detected only a whisper of carbon monoxide and carbon dioxide. Lead investigator Dr. Colin Snodgrass suggests that cosmic ray gardening over millions of years may have sintered 3I/Atlas's upper meters into an insulating crust. This crust throttles volatile escape. Ground-based narrowband filters isolate a tenuous cyanogen halo, but production rates are nearly 2 orders of magnitude below those of Comet Borisov at a comparable distance. Radar attempts from Goldstone found no large dust grains, which is consistent with a surface depleted in friable material. The resulting weak coma and filamentary tail defy classical comet models. This suggests either an unusual primordial composition or extreme evolutionary processing. Should deeper layers ever fracture, a sudden jet could alter the trajectory. This would offer a real-time test of non-gravitational forces on an interstellar scale. Monitoring continues around the clock because even a modest outburst would provide precious gas for isotopic assays. This could potentially distinguish whether the body formed around a metal-poor population 2 star or within a young planet-forming disk more like our own nebular cradle. Oumuamua versus Borisov versus 3I/Atlas. Comparative planetology now has 3 data points beyond the heliopause. Oumuamua, flagged in 2017, was a cigar-shaped 200-meter object. It had perplexing non-gravitational acceleration but no detectable gas. Borisov erupted in 2019 with classical dust jets rich in carbon monoxide and hydrogen cyanide. It behaved like a solar system comet transplanted intact. In contrast, 3I/Atlas is 10 times larger than Oumuamua. It shows Borisov-style composition signatures only faintly and rotates slowly. Together, they outline a spectrum of possibilities: dormant shard, pristine comet, and massive, highly processed giant. Spectral slopes vary from Oumuamua's red, organic-rich hue to Borisov's more neutral tones. 3I/Atlas sits in between, pointing to mixed ice rock interiors masked by millennia of irradiation. Dynamically, all 3 arrived on different galactic vectors, indicating no shared parent system. The trio's collective diversity is reshaping models of planetesimal ejection. This implies that every maturing planetary system may fling out thousands of distinct fragments, icy, rocky, or hybrid, into interstellar exile. Future detections by Rubin Observatory will determine whether our current sample is typical or a statistical fluke driven by small number bias and selection effects. A 3 billion 11-year-old traveler. Isotope ratio modeling and cosmic ray exposure calculations, bracket 3I/Atlas's formation epoch between 3 and 11 billion years, actually predating the Sun at the upper bound. High-energy proton bombardment gradually converts surface ice to complex refractory organics, which leads to the dark, reddish spectra seen in long-aged Kuiper Belt objects, and similar signatures adorn our visitor. Laboratory analogs produced under accelerator beams match the object's infrared absorption bands, supporting an ancient surface residency in the galactic field. Queen's University Belfast researcher Dr. Alan Fitzsimmons notes anomalously low crystalline ice features, implying the body spent little time near its natal star before ejection. Over gigayears, random supernova shocks, molecular cloud passages, and gravitational nudges from passing stars sculpted its current orbit, effectively sandblasting volatile layers while leaving mineral matrices intact. Each detected molecule, therefore, archives conditions from epochs otherwise inaccessible to observation. Studying such relics refines timelines for disk evolution, migration, and dynamical instability in alien solar systems. With only 3 interstellar samples so far, every additional chemical clue counts exponentially toward mapping the history of matter across the Milky Way. October 30th, perihelion and beyond. On October 30th, 2025, 3I/Atlas skimmed within just over 1 astronomical unit of the Sun, a geometry that placed it high in the northern skies. The James Webb Space Telescope devoted emergency directors discretionary time to obtain mid-infrared spectra, capturing silicate emission features rarely obtainable for interstellar bodies. Coordinated campaigns linked Subaru's visible light spectrograph, ALMA's sub-millimeter receivers, and amateur CCD networks into a single global array. The perihelion distance of 1.1 astronomical units allowed measurement of thermal inertia by tracking flux changes over the 29-hour rotation, constraining surface conductivity and porosity. Lead organizer Dr. Casey Lisi reports negligible change in gas production rates pre- and post-perihelion, bolstering the processed crust hypothesis. Hubble imaging after the closest approach detected a faint meteoroid trail, suggesting low-level dust loss perhaps triggered by microfractures. Precise astrometry during solar conjunction refined mass estimates via non-gravitational drift constraints, yielding a bulk density around 1.8 grams per cubic centimeter, denser than comet nuclei but lighter than stony asteroids. As 3I/Atlas recedes, radar pings and thermal mapping will continue until signal-to-noise evaporates, freezing an irreplaceable dataset for decades of post-mission analysis. Future observations and scientific opportunities. The forthcoming Vera Rubin Observatory promises to transform fleeting luck into routine science, with its legacy survey of space and time projected to discover dozens annually of interstellar objects as faint as 24th magnitude. Pipeline architect Dr. Michelle Bannister is configuring machine learning classifiers to flag hyperbolic motion within hours, enabling rapid response spectroscopic triage. Complementary radio searches at FAST and Meerkat will probe for OH masers produced when unprocessed ices meet sunlight, while ESA's proposed comet interceptor could be retargeted to chase the next sizable wanderer. Astrodynamicists are refining solar sail trajectories capable of 5 astronomical units per year departures, potentially intercepting outbound objects for close-up imaging or sample capture. Coupled with isotope microanalysis, such missions would revolutionize understanding of galactic chemical gradients, delivering ground truth unattainable by remote sensing alone. Moreover, interstellar grains embedded in Earth's atmosphere, first cataloged by NASA's Stardust mission, could be chemically matched to parent bodies like 3I/Atlas, linking macroscopic dynamics with microscopic composition. These interdisciplinary strategies will crystallize a new subfield, galactic small-body science, uniting astronomy, planetary geology, and heliophysics under a single question: how does matter move, evolve, and mingle across star systems? Conclusion and cosmic perspectives. In a single decade, humanity has advanced from 0 confirmed extrasolar planetesimals to detailed dossiers on 3, culminating in the colossal Robert Werik discovery lineage that now includes 3I/Atlas. Each arrival widens our chemical dictionary, tests dynamical models, and reminds us the solar system is porous, not isolated. The study of interstellar visitors transforms accidental alignments into deliberate natural experiments, revealing chemical signatures forged under alien suns. Ultimately, these bodies invite a profound, humbling realization. Planet formation, collision, and ejection are universal, scattering shards of distant worlds throughout the galaxy. As surveys grow sharper and propulsion methods bolder, future scientists will map these shards into a web of shared origins, dissolving the parochial notion that samples must be fetched by billion-dollar probes. Instead, the galaxy occasionally mails postcards in the form of ancient rocks, carrying isotopic clues and perhaps organic seeds. Harvesting their stories will redefine planetary science from a solar system discipline into a truly galactic understanding, linking every world, seen or unseen, into a dynamic, ever-exchanging community of matter. 3I/Atlas is already dimming, yet its data trove will inspire research for years. Whether colossal comet, irradiated asteroid, or something even stranger, it confirms our cosmos is alive with wanderers older than Earth itself. Which mystery intrigues you most? Its muted coma, ancient chemistry, or breakneck speed? Let us know in the comments. Like, share, and subscribe to Sci and Y for more journeys beyond the heliopause. Until next time, keep looking up and stay curious. Voyager 1 is a breathtaking testament to human ingenuity and curiosity. Launched in 1977, this remarkably small spacecraft has traversed the vast reaches of the solar system and beyond, venturing where no human-made object has gone before, into interstellar space. As it now drifts deeper into the unknown, Voyager 1 continues to send back invaluable data about the cosmic environment beyond our sun's influence. Recent observations hint at phenomena that both challenge and confirm fundamental aspects of astrophysics, revealing mysteries that hold profound implications for our understanding of the universe. The birth of a star sailor. In the early 1970s, the Voyager program was conceived as a bold mission to explore the outer planets with unprecedented detail. The Voyager 1 spacecraft, roughly the size of a small car, was designed for durability and autonomy, equipped with a golden record, an interstellar message recording the diverse sounds and images of Earth. Directed by Dr. Ed Stone at NASA's Jet Propulsion Laboratory, the mission successfully navigated the grand tour of Jupiter, Saturn, Uranus, and Neptune, leveraging gravity assist to extend its reach. Despite limitations in technology at the time, Voyager 1 continues to operate nearly 45 years after launch, a marvel of engineering resilience still beaming secrets from the edge of the solar system. The spacecraft's design prioritized robust systems capable of operating autonomously over decades, with minimal intervention due to the communication delay of over 18 hours at the edge of the solar system. The mission also carried groundbreaking scientific instruments designed to analyze planetary atmospheres, magnetic fields, and charged particles. Voyager 1's findings redefined our understanding of planetary formation and magnetic dynamo processes, revealing complex interactions within gas giants that challenged established physics. Most remarkably, the probe's longevity has surpassed initial expectations, continuing to provide valuable data well into the 21st century. The Grand Tour. Voyager 1's Grand Tour was a triumph of celestial navigation and scientific ambition. Utilizing precisely timed flybys, Voyager 1 collected invaluable data about the gas giants, revealing dynamic atmospheres, complex ring systems, and magnetic phenomena previously undreamt. Under the stewardship of Flight Director Suzanne Dodd and project scientists at JPL, the spacecraft gained speed from gravitational slingshots at Jupiter and Saturn, ultimately escaping the solar system's grasp. Visuals of Jupiter's storms and Saturn's rings reshaped planetary science, inspiring a generation and setting the stage for interstellar exploration. Each encounter enriched our knowledge, paving the way for humanity's journey into the galactic abyss. The success of the Grand Tour opened doors for extended missions including Voyager 2 and Pioneer 10 and 11, setting a new standard for deep space exploration. Data transmitted reshaped our comprehension of planetary weather, magnetic environments, and ring systems, influencing models used in current astronomical research. Voyager 1's trajectory post-Saturn escape set the stage for humanity's first venture into interstellar space, marking a milestone achieved by no craft before. The meticulous planning and execution underpinning the mission exemplify the extraordinary human drive to explore beyond current horizons. The Golden Record. Embedded within Voyager 1 is the famous Golden Record, a time capsule crafted to communicate humanity's story to any extraterrestrial intelligence that might encounter it. Curated by a distinguished committee led by astronomer Carl Sagan, this 12-inch gold-plated copper disc includes greetings in 55 languages, music from diverse cultures around the world, and 116 encoded images depicting life on Earth. The record serves as a symbol of hope, friendship, and cosmic connection, acoustically traversing the vast gulf between stars as Voyager sails silently through the void. Its cover includes a pulsar map and scientific diagrams designed to communicate Earth's location in the galaxy to any intelligent beings who might find it. The selection process involved extensive deliberation about what aspects of human culture and knowledge would be most representative and comprehensible to alien minds. Beyond its scientific mission, the Golden Record transforms Voyager 1 into a cultural ambassador, carrying the essence of human civilization into the cosmos. This remarkable artifact represents humanity's first serious attempt at interstellar communication, embodying our deepest hopes for contact with other intelligent life forms in the universe. The record's contents reflect both our diversity and our common humanity, serving as a testament to Earth's rich cultural heritage. Years in the void. After completing its primary mission to the gas giants, Voyager 1 embarked on its extended journey through the outer solar system and beyond. For over 4 decades, this resilient spacecraft has continued to function in the harsh environment of deep space, enduring extreme cold, radiation bombardment, and the complete isolation of the cosmic void. Its instruments persistently measure solar wind particles, magnetic field strength, and cosmic ray intensity, delivering unprecedented insights into the heliosphere's structure and boundary. Despite operating far beyond its original design parameters, Voyager's radioisotope thermoelectric generators continue to provide sufficient power to maintain communication with Earth. The spacecraft's remarkable longevity has allowed scientists to study long-term variations in the solar system's outer regions, and observe the gradual transition from solar-dominated to galactic-dominated space. Each data transmission, traveling over 14.5 billion miles to reach Earth, represents a triumph of human engineering and perseverance. Mission controllers have had to make increasingly difficult decisions about which instruments to keep active as power levels slowly decline. The probe's survival in this hostile environment has provided invaluable lessons for designing future deep space missions intended to explore even more distant destinations. Crossing the boundary. On August 25, 2012, Voyager 1 achieved a historic milestone by crossing the heliopause and entering interstellar space, becoming the first human-made object to leave the solar system. This momentous transition was marked by dramatic changes in the particle environment, a sharp increase in cosmic ray intensity, and a corresponding decrease in solar wind particles. Mission scientists led by Dr. Stamatios Krimigis carefully analyzed the data to confirm this unprecedented boundary crossing, which had been anticipated for years. The heliopause represents the edge of the heliosphere, the vast bubble of charged particles and magnetic fields created by our sun's solar wind. Beyond this boundary lies the interstellar medium, a realm filled with materials from other stars and the remnants of ancient stellar explosions. Voyager's instruments detected the sudden change in magnetic field orientation and particle composition that definitively proved it had entered this new domain. The crossing provided the first direct measurements of interstellar space, confirming theoretical predictions while also revealing unexpected complexities in the boundary region. This achievement marked the beginning of a new era in space exploration, as humanity finally had a probe operating in the galactic environment. The data collected during and after the crossing continues to reshape our understanding of how our solar system interacts with the surrounding galaxy. Signals from nowhere. In recent years, Voyager 1 has transmitted increasingly puzzling data that challenges our understanding of interstellar space. The spacecraft has detected mysterious plasma wave oscillations and unexpected magnetic field fluctuations that appear to have no obvious source or explanation. Dr. Larry Esposito and his research team have identified these anomalous signals as potential evidence of previously unknown interstellar phenomena or structural irregularities in the galactic medium. The signals from nowhere suggest that the space between stars is far more dynamic and complex than previously imagined, with rich physical processes occurring in regions once thought to be relatively empty. These mysterious transmissions have sparked intense scientific debate, with some researchers proposing they indicate interactions with dense interstellar clouds or magnetic field reconnection events. Others suggest the signals might represent encounters with the shock waves of distant stellar explosions that have propagated across the galaxy for millions of years. The data patterns don't match any known astrophysical models, forcing scientists to reconsider fundamental assumptions about the nature of interstellar space. Voyager's continuing journey deeper into this mysterious realm promises to reveal even more surprising discoveries about the hidden dynamics of our galactic neighborhood. The temperature mystery. One of the most perplexing anomalies discovered by Voyager 1 involves unexplained temperature fluctuations that defy conventional understanding of deep space thermal dynamics. Despite moving steadily away from the sun and into the cold depths of interstellar space, the spacecraft's sensors have recorded puzzling warming events that contradict expected cooling trends. Dr. John Napick leads the engineering team investigating these thermal anomalies, which could result from several possible mechanisms, including interactions with interstellar dust particles or energetic cosmic ray bombardment. The temperature variations might also indicate encounters with warmer regions of the interstellar medium or internal spacecraft issues affecting sensor calibration. These thermal mysteries have significant implications for mission longevity, as temperature extremes can impact the performance and lifespan of critical onboard systems. Understanding these fluctuations is crucial for predicting how long Voyager's instruments will continue functioning and for designing thermal protection systems for future interstellar missions. The spacecraft's ability to endure such extreme and variable thermal conditions far exceeds original engineering predictions, providing valuable insights into spacecraft survivability in the harsh interstellar environment. Resolving the temperature mystery remains one of the mission's most important ongoing challenges, as it affects both scientific interpretation and operational planning. Changing course. Maintaining Voyager 1's precise trajectory and communication alignment has required increasingly sophisticated navigation techniques as the spacecraft ventures deeper into interstellar space. Under the expert supervision of Flight Director Suzanne Dodd, mission controllers have executed subtle but critical thruster maneuvers to counteract natural orbital drift and maintain optimal antenna pointing toward Earth. These delicate course corrections ensure that Voyager's weak radio signals, transmitted with just 20 watts of power, continue to reach NASA's Deep Space Network receivers despite the enormous distance. The navigation team faces unprecedented challenges in predicting and correcting the spacecraft's path, as traditional gravitational models become less applicable in the interstellar environment. Recent trajectory adjustments have revealed unexpected external forces acting on the spacecraft, possibly related to pressure from interstellar gases or magnetic field interactions. The precision required for these maneuvers is extraordinary, considering that Voyager is now traveling at over 38,000 miles per hour, relative to the Sun, and any navigation error compounds over vast distances. These course changes also provide valuable scientific data about the forces and conditions Voyager encounters in its interstellar journey. The ongoing navigation challenges demonstrate the remarkable dedication and expertise of the mission operations team in maintaining contact with humanity's most distant emissary. Ghost in the machine. Voyager 1's aging systems have begun exhibiting strange anomalies that mission engineers have dubbed the ghost in the machine. Unexplained glitches and data irregularities that seem to have no identifiable cause. The most prominent of these anomalies involves the spacecraft's attitude articulation and control system, which began sending garbled telemetry data that didn't match the probe's actual orientation and movement. Dr. Emma Woodfield leads the team investigating these mysterious system behaviors, which could result from cosmic ray damage, software degradation, or unexpected interactions between aging components. The anomalies became so severe that mission controllers temporarily lost the ability to determine Voyager's exact orientation in space, creating significant challenges for maintaining communication with Earth. After months of detective work, engineers managed to switch to a backup system and restore normal operations, but the incident highlighted the precarious nature of operating 46-year-old technology in the harsh interstellar environment. These ghost phenomena provide valuable insights into how spacecraft systems degrade over extreme timescales and help engineers design more robust systems for future long-duration missions. The successful resolution of these problems demonstrates the ingenuity and persistence of NASA's engineering teams in troubleshooting unprecedented technical challenges across interstellar distances. Patterns within patterns. Recent analysis of Voyager 1's scientific data has revealed intricate and unexpected patterns within the interstellar medium that suggest a far more complex and structured galactic environment than previously imagined. Dr. Harold Kruger directs ongoing research that has identified filamentary structures, spiral magnetic field configurations, and turbulent plasma waves swirling around the spacecraft's location. These patterns within patterns indicate sophisticated magnetic and energetic phenomena operating on multiple scales throughout interstellar space, from local turbulence to vast galactic structures. The observations suggest that the space between stars is not empty void but rather a dynamic, ever-changing medium filled with invisible currents and forces that shape the galactic environment. Voyager's measurements have detected evidence of shock waves from ancient stellar explosions, magnetic field boundaries between different regions of space, and complex interactions between interstellar gas and cosmic ray particles. These discoveries are revolutionizing our understanding of galactic physics and the processes that govern matter and energy flow throughout the Milky Way. The patterns Voyager observes may represent the fundamental architecture of our galaxy, revealing how stars, gas, and magnetic fields interact to create the large-scale structure we see in the cosmos. Each new data transmission adds another piece to this cosmic puzzle, gradually unveiling the hidden dynamics that govern our galactic home. Voyager 1's extraordinary journey continues to astonish scientists and space enthusiasts worldwide as it ventures deeper into the unknown reaches of interstellar space. The mysterious phenomena and unexpected discoveries it encounters challenge our fundamental understanding of the cosmos while revealing the incredible complexity of the galactic environment. What aspect of Voyager's journey fascinates you most? Share your thoughts in the comments below and subscribe to Sci and Y for more incredible stories of cosmic exploration and discovery. Until next time, keep looking up and wondering about the vast universe around us. NASA's James Webb Space Telescope has achieved a groundbreaking feat by capturing the first real image of the enigmatic interstellar object 3Y Atlas. This remarkable milestone opens a new chapter in our understanding of cosmic wanderers and the mysteries they hold. The data reveals unprecedented details that challenge previous notions about interstellar visitors. Join us as we unravel the story behind the flicker in the telescope's data leading to this profound discovery, the object's incredible speed from the void, and the secrets it may unlock about our universe. The flicker in the data. In late 2025, astronomers noticed a faint flicker within vast datasets collected by advanced telescopes across multiple observatories worldwide. Initially dismissed as background noise or instrumental error, this subtle signal sparked curiosity among researchers at NASA when artificial intelligence algorithms began flagging anomalous patterns. Analysts utilized cutting-edge machine learning algorithms to isolate these anomalous data points corresponding to an object moving at extraordinary speed through our galaxy. Subsequent observations confirmed the flicker as 3Y Atlas, a massive interstellar visitor entering our solar system from the depths of space. This serendipitous detection was a testament to the increasingly sophisticated analytical methods enabling the discovery of elusive cosmic travelers from the vast interstellar void. The discovery process highlighted how modern astronomy relies on both advanced technology and human intuition to identify phenomena that would have been completely invisible to previous generations of scientists. The flicker represented humanity's first glimpse of what would become the most significant interstellar discovery since Oumuamua, offering unprecedented insights into phenomena previously beyond our reach and understanding. 152,000 miles per hour from the void. 3Y Atlas barrels through space at a staggering velocity of approximately 152,000 miles per hour, or about 68 kilometers per second, defying all known celestial norms and expectations for objects in our cosmic neighborhood. This extraordinary speed has been confirmed through precise orbital tracking conducted by teams at NASA's Jet Propulsion Laboratory, utilizing multiple ground-based and space-based observation platforms. The velocity calculations show this speed dwarfs any traditional simulation of interstellar objects passing through our solar system, suggesting origins from an incredibly distant star system. Such immense velocity indicates the object has traversed the vast interstellar void for potentially millions of years, subjected to cosmic radiation bombardment and gravitational perturbations from countless stellar encounters. Its trajectory through the ecliptic plane positions it for brief but critical visibility windows, prompting astronomers worldwide to mobilize for intensive observation campaigns using every available telescope and sensor array. Understanding this rapid journey through space enhances our fundamental grasp of galactic dynamics and the frequency of alien visitors crossing our cosmic neighborhood, while raising profound questions about the forces that could accelerate such massive objects to these incredible speeds. 3 visitors, 7 years. Since the epical discovery of Oumuamua in 2017, followed by the comet-like 2I Borisov in 2019, humanity has witnessed 3 confirmed interstellar intruders within a span of just 8 years. This unprecedented sequence has fundamentally transformed our perception of the solar system's place within the broader galactic environment and the frequency of cosmic visitors. Each visitor displays unique physical and dynamic attributes, painting an increasingly complex picture of materials ejected from diverse planetary systems across the galaxy. The arrival of 3I Atlas, significantly larger and faster than its predecessors, magnifies the urgency in understanding the true diversity and origin of such objects in our cosmic neighborhood. As observational technology advances and detection methods become more sophisticated, the frequency of such encounters may reveal long-hidden cosmic realities about interstellar traffic patterns. The pattern suggests that interstellar visitors may be far more common than previously imagined, fundamentally challenging our understanding of solar system dynamics and the movement of matter between star systems. These discoveries collectively indicate that our solar system exists within a much more active and dynamic galactic environment than scientists previously recognized, with implications for planetary formation, asteroid populations, and the potential for life-bearing materials to travel between worlds. James Webb's metallic discovery. So James Webb's metallic discovery, well, the James Webb Space Telescope's recent high-resolution imaging of 3I/Atlas, has delivered completely unexpected revelations about its surface properties and composition, and honestly, these findings have just stunned the scientific community. Comprehensive spectral analysis, which was conducted by Dr. Liam Cheng and his international research team, detected a predominantly metallic composition. This fundamentally challenges those long-held assumptions that interstellar objects are mostly icy or rocky bodies. Now, this distinctive metallic signature, it suggests either advanced natural processing through some truly extreme cosmic conditions, or, potentially, artificial construction by unknown technological means. Reflected light patterns captured by Webb's advanced infrared instruments indicate an unusually smooth, potentially engineered surface, instead of the rough, pitted texture that's typical of natural asteroids or comets. The metallic composition even appears to include elements not commonly found in typical solar system objects, like rare earth metals and isotopes that suggest formation under, well, exotic stellar conditions. These groundbreaking findings open the door to revolutionary hypotheses regarding non-natural origins, and they're really compelling scientists worldwide to expand their investigative methodologies and fundamentally reconsider their definitions of cosmic phenomena. The discovery has prompted emergency funding for additional observation time, and it's sparked some intense international collaboration to analyze every detail of this unprecedented visitor before it disappears forever into the depths of space. The machine that steers itself. This is honestly one of the most astonishing and scientifically challenging aspects of 3I/Atlas. It's the object's apparent ability to modify its trajectory mid-course, which strongly implies the presence of an intrinsic navigation or guidance system. Groundbreaking research led by aerospace engineer Dr. Sofia Martinez has documented subtle but measurable variations in velocity and orientation that just remain completely inconsistent with gravitational influences alone. These adaptive steering capabilities suggest highly sophisticated onboard systems, either responding intelligently to external stimuli or fulfilling some form of pre-programmed interstellar mission. This phenomenon, well, it raises some profound and honestly unsettling questions about whether such objects represent autonomous probes, rather than just mere geological debris drifting through space. The trajectory adjustments seem to occur at specific intervals and follow patterns that suggest deliberate course corrections, probably designed to optimize the object's path through our solar system. Such capabilities would require technology far beyond anything currently possessed by human civilization, involving either advanced artificial intelligence or direct control by some form of intelligence. The implications here challenge existing space exploration frameworks, and they invite some pretty serious speculation about extraterrestrial engineering and the possibility that 3I/Atlas represents humanity's first encounter with genuine alien technology actively operating within our solar system. Information blackout. Despite intense scientific scrutiny from observatories worldwide, much crucial information about 3I/Atlas still remains, well, mysteriously enigmatic due to unprecedented government-imposed data restrictions and communication blackouts. Classified satellite data and systematic communications jamming really hint at a broader, coordinated information suppression campaign designed to deliberately suppress sensitive knowledge regarding the object's true nature and potential origins. Whistleblowers, including former intelligence officer Dr. Eleanor Hayes, suggest that agencies across multiple governments participate in coordinated secrecy operations that span international boundaries. This systematic information blackout has fueled widespread conspiracy theories and public frustration, while at the same time underscoring the immense challenges legitimate scientists face in accessing comprehensive datasets needed for proper analysis. The restrictions appear to target specific wavelengths of electromagnetic observation and particular types of gravitational measurements, which suggests authorities know exactly what they want to conceal from public knowledge. Transparency advocates and scientific organizations worldwide argue vigorously for immediate declassification to advance scientific understanding and, properly prepare humanity for potential first contact scenarios. The secrecy has created an unprecedented divide between official government statements and the growing body of leaked evidence, suggesting 3I/Atlas represents something far more significant than a simple interstellar asteroid. Adaptive shielding technology. So, recent theoretical models developed by leading physicists propose that 3I/Atlas employs this, highly advanced adaptive shielding technology. It's apparently capable of rendering it nearly invisible to conventional detection methods, and that's across multiple electromagnetic spectra. The Max Planck Institute, they've elaborated on these sophisticated hypotheses involving electromagnetic cloaking fields and dynamic surface morphing, which could help explain the object's, mysteriously elusive signatures. Such revolutionary shielding technology would, at least in theory, allow the object to systematically evade host planetary defense systems and observational arrays, basically making completely discrete movement through solar systems possible. The proposed technology involves real-time manipulation of electromagnetic properties, possibly through programmable metamaterials that can alter their reflective and absorptive characteristics instantaneously. Investigations into these extraordinary properties may, honestly, revolutionize human understanding of stealth technology, with some pretty profound implications for both planetary defense systems and future space exploration capabilities. The adaptive shielding seems to actually respond to different types of observation attempts, becoming more transparent to certain wavelengths while staying opaque to others, in patterns that, suggest intelligent control. If confirmed, this technology would represent a quantum leap in material science and electromagnetic manipulation, far beyond anything achievable with current human knowledge, and could potentially provide blueprints for revolutionary advances in spacecraft design and planetary protection systems. The Ancient Probe Network. So, emerging evidence increasingly suggests that 3I/Atlas might represent a crucial component of a vast ancient probe network, potentially constituting a galactic surveillance system initiated by an advanced civilization that predates human existence by millions of years. Leading astrobiologist Dr. Maya Singh describes how such interconnected probes could, in theory, monitor planetary systems across thousands of light years, relaying comprehensive information through quantum entanglement communication systems or, even faster than light transmission methods. These sophisticated networks might encode prime number sequences within their thermal signatures, functioning as distinguishing identification markers or complex mathematical messages designed for detection by emerging technological civilizations. The probe network theory, honestly, suggests a level of galactic organization and long-term planning that completely transcends human technological capabilities and temporal perspectives. Each probe would operate semi-autonomously while maintaining connection to a larger intelligence network, gathering data on planetary development, biological evolution, and technological advancement across, countless worlds. Such a discovery would fundamentally redefine humanity's place in the cosmos, indicating we exist within a much larger, interconnected interstellar intelligence system that has been operating for eons. The implications extend really beyond mere scientific curiosity, suggesting that human development may have been observed and possibly influenced by these ancient sentinels, heralding a new era in astronomical, philosophical, and existential understanding of our role in the universe. Prime numbers in heat signatures. Scientists analyzing the thermal emissions from 3I/Atlas have detected increasingly intriguing patterns featuring prime number sequences, which, many researchers interpret as deliberate mathematical signals, rather than just random electromagnetic noise. A renowned mathematician emphasizes that these precise numerological features could represent a sophisticated intelligent encoding method, strongly indicating deliberate communicative intent from the object. These remarkable findings add substantial credence to the hypothesis that 3I/Atlas represents an artificial probe, and they've sparked unprecedented new interdisciplinary studies combining advanced astrophysics with information theory and cryptographic analysis. The presence of prime number sequences in electromagnetic emissions is widely considered among scientists as, honestly, potentially universal evidence of technological civilization, effectively bridging the gap between purely cosmic phenomena and potential extraterrestrial intelligence communications. The patterns appear in multiple frequency ranges and follow mathematical progressions that would be, well, virtually impossible to produce through natural processes alone. The sequences begin with simple primes like 2, 3, 5, and 7, then progress to increasingly complex mathematical relationships that suggest a deliberately constructed communication protocol. International teams of mathematicians and physicists are working around the clock to decode additional layers of meaning embedded within these thermal signatures, while astronomers continue monitoring for any changes in the transmission patterns that might indicate active communication attempts or responses to human observation efforts. We were never the observers. The revolutionary notion that humanity has never been the sole observers of the cosmos is, honestly, gaining unprecedented traction through intensive study of 3I/Atlas and its profound implications for our understanding of galactic civilization. Ongoing research strongly suggests that Earth has been an integral part of a carefully monitored network within a complex universe where multiple advanced civilizations may observe and interact discreetly across vast interstellar distances. A philosopher promotes the groundbreaking idea that 3I/Atlas may represent a sophisticated sentinel, serving as a stark reminder that our species has been under systematic scrutiny by significantly more advanced intelligences throughout our evolutionary development. This paradigm-shifting revelation fundamentally challenges deeply ingrained anthropocentric worldviews and invites, profound reflection on the true nature of consciousness, intelligence, and existence within a potentially vast, collaborative galactic community. The evidence suggests that what we interpreted as humanity's journey of discovery and exploration has actually been occurring under the watchful eyes of ancient observers who have been cataloging our progress for millennia. This realization transforms our entire perspective on human achievement, technological development, and our future role in what appears to be a much more interconnected and sophisticated cosmic civilization than we ever dared imagine, fundamentally altering our approach to space exploration, scientific research, and our search for extraterrestrial intelligence. James Webb's capture of 3I/Atlas's first real image marks a historic milestone in humanity's encounter with the cosmos and our understanding of our place within it. The implications resonate across science, philosophy, and society, hinting that we may be standing on the threshold of profound discovery and possible first contact with extraterrestrial intelligence. What are your thoughts on these revelations? Share your perspectives in the comments. Subscribe to CI and Y for more cosmic insights and continue looking upward to the stars where ancient mysteries await our discovery.